So at this point, you guys, you should have done the warm-up, and these are the answers. I am going to talk through it a little bit and the reasoning as to why each answer is the way it is. So if you are checking your answers and you got them all right and you have a strong understanding, obviously please feel free to fast forward a little bit until I start talking about domain range increasing and decreasing below. So when I looked at these graphs, there were a couple things that were pretty clear to me and the differences between them. First, the breaking points. These two have breaking points at 0. And then this is a breaking point at 1. This does 2. This does 2. And then this is a breaking point at -1. So I would look through here. This is the only one that has a breaking point at -1. And therefore, that has to be C because that's the only one that has a breaking point right there at -1. So that's how I got that answer. From there, the next two easiest, so this one was done. From there, the next two easiest were these breaking points at 0. Well, the two that have breaking points at 0 were B and F. So then I took a look at it and said, okay, breaking points at 0. This has 2x plus 3 if x is greater than or equal to 0. Okay, so the 2x plus 3 has to be on the right-hand side. This is x plus 4 if x is less than 0. So the y-intercept here is going to be 0, 3. The y-intercept here is going to be 0, 4. Down here, same thing. X plus 4 has a y-intercept of 0, 4. 2x plus 4 has a y-intercept of 0, 4. Cool. Well, then you just need to look and see which one has the same y-intercept. So the same y-intercept is at B, so that's how number 3 became the answer of B. And then here, notice there's a difference between a y-intercept of 3 and a y-intercept of 4, so that's how that one became F. So now we have all of those done. Now, the only thing you need to pay attention to is the last 3 remaining that all have the same breaking point. So, if you look at A, we clearly have a horizontal line there, but not at D and not at E. Well, of the 3 remaining, number 1, number 5, and number 6, the only one that should have a horizontal line at all in the graph is number 6 because of that -5. So that's why number 6 is A. Then, you're down between D and E. So, we are left with numbers 1 and 5. Number 1 and number 5, this has a y-intercept of 0, -4, and a y-intercept of 0, 0. So if you look here, this graph and this graph, this one is x minus 4 if x is less than 1. And this is 3x if x is greater than 1. So you're not actually going to see this because it's not in the right section. So then I'm going to look for the one that has 0, -4. Well, that's -2. This is -4. So this has to be E, and then the last one has to be D. So, you know, just use power of elimination. I did, obviously, the breaking points first. That got me down. And then I looked at the type of graphs that you had. Okay. All right. So what we're doing today, we've spent 2 days graphing these. Now, what we're going to do today, and this is the last day, tomorrow is going to be kind of a catch-all work day, so make sure you definitely bring questions if you still have any remaining tomorrow to class. This says, determine the domain and range, which we've already done, and where it's increasing and decreasing. Okay, so that's the new part. So, again, domain and range. Domain is left, right. Range is up and down. So you're looking for those arrows first, but then you're also looking for breaks in the graph. So in this case, my domain, I clearly don't have an arrow to the left. The smallest x value that I have there is happening at -5. And that's an open circle, so it has a parenthesis. As I come across, this is on the same x value, so there's not a break in your domain. You keep going, and you have an arrow to the right, so your domain is 5 to infinity. With your range, you guys don't look at just the picture. Look at the arrows, because this arrow, it cuts off here, but it actually keeps going. So our range is going to start at -infinity because of that arrow. Now, we don't have an up arrow, so we're going to have a value for our range at the end. And here, I am coming up from the bottom. There are no breaks, you know, where you have to like jump from one to the other. Everything going across has something accounted for. So the highest y value you have there is 4. That is an open circle as well, so that's a parenthesis. Now, let's talk about increasing, decreasing. I'm going to use highlighters here to make it a little easier, so feel free, obviously, if you have highlighters, to grab them. I mark up the graph first. Remember, increasing, decreasing, you always read like a book, left to right. Always, always, always. So here, I'm going to do my decreasing in yellow, and I will do my increasing in blue. I am decreasing right here. I hit that point, so it's a point of change, and I start increasing. I hit this point, and then I just need to jump to the next graph. Well, if you notice, when you jump to the next graph, that graph is still increasing until it hits the vertex there, and then it starts decreasing again. Okay, so let's think about this. We are, remember, increasing and decreasing is x values. So we are increasing from here, decreasing from here to here. Okay, so that is a decrease. Then I hit that x value and I start increasing. Well, I'm increasing, that's all blue until this x value. So notice I didn't care that I switched from one part of the function to the next. I'm just looking and saying from here to here it's all blue. So that's all increasing. Okay, then I hit this point and I start decreasing again. Okay, so the reason I'm doing it at the top left to right is because I'm using x values, and that visually will help you if you kind of do it that way. So let's think about this. We start decreasing at the x value of -5, but it's an open circle, so we start decreasing at parentheses -5. We decrease until the x value of -3. Now, just like last unit, that's a vertex, it's a critical point, that's a point of change. So that is also going to be a parenthesis. At that point, I start increasing. So I'm increasing starting at -3. So I'm still right here on my graph, you guys. And I'm going to increase all the way until I hit the x value of +3. Again, that's a vertex, that's a point of change, so it's a parenthesis. Then I start decreasing again. So put your u in there because you have another part of decreasing that starts at the x value of 3 and it goes to infinity because of the arrow. Okay, when you look at increasing and decreasing and you can look at it horizontally like I did up at the top, it's going to make your life a lot easier. Okay, all right, so let's do it again here. Domain and range. My smallest x value. Oh, and if you notice, you guys, my domain was -5 to infinity, and that kind of matches. Even though we were switching between increasing and decreasing, that should kind of help you out. My smallest x value here is -2. That is a closed circle. So I'm starting my domain at -2. I chug along until I hit here, but then I pick up my other graph, and I go on forever because of the arrow. So it's -2 to infinity. Now, with our range, again, bottom to top, this arrow tells me I am starting at -infinity. And I am going to come up from -infinity until I hit this open circle. Well, there isn't another graph to jump onto here, right? If I look left, if I'm standing here and I look left or right, there's nowhere to go but jump up to right here. So that's going to be a break in our range. And then I go up until I am here. Okay, so imagine you're kind of like, this is just up and down. You're kind of walking up. You walk up, 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 all the way from -infinity. You hit this point. You look left or right. There's nowhere to kind of slide over and keep going, so you have to jump. So that tells me that my range goes from -infinity to 2 with a parenthesis because that's an open circle. There is a break right here in your range. So that is going to be a u. And then I have another set of y values from +4 to +5. Both are closed circles, so those are both brackets. Okay. Now, let's do our increasing and decreasing. I'm going to do the same thing. I'm going to use the highlighter. I will decrease just to stay consistent with yellow, and I will increase with blue. So, x values. We start from the left and we are increasing, so I'm going to stay with blue. So from here I'm going up, so that's increasing. Then once I get here, In this case, when I switched, my graph was still increasing, but in this case, when we switch to the other part of the graph, it's decreasing. So I'm decreasing, and this is a cubed root graph, so that's going all the way. So that means when I look at this, I am increasing, starting at this x value to this x value. So that's an increase. Okay. Then I start decreasing once I hit this x value, and I decrease forever. Okay. If you're finding values other than your domain, something's wrong with one or the other. So I am increasing. You guys, this is a closed circle, and there's nothing going on the other side of it. The only thing you can do is increase, starting at the x value of -2. So that's a bracket. You increase until the x value of 2. Now notice, you guys, these aren't connected, right? So I am going to put a bracket there. Okay. I am increasing from -2 to 2. That is inclusive. It's not technically a point of change because they don't share that value. Then I start decreasing. That's an open circle. So I'm going to start decreasing at 2 with a parenthesis. And I'm going to decrease to infinity. Oops. Let's try that on for size. That's nothing. 2 to infinity with a parenthesis. Okay. All right, now on the back, we're going to do the same thing, but now we're adding in actually writing the graph. Okay, so let's focus on the domain range increasing and decreasing, and then we will write the graph. So my domain, left to right, I have an arrow going to the left. Awesome. So I'm going to start with -infinity. My domain chugs along. I hit this point, but then my graph drops down, picks right back up. So my domain is -infinity to infinity. My range, I have 2 arrows going down. Sweet. So I'm definitely starting from -infinity. When I come up, this graph ends, but this graph has already started. So I can slide right over, and I'm going to go up until I hit this point. That's the highest point in the range. So my range is -infinity to -1 with a bracket because that's a closed circle. Now, increasing and decreasing. Let's switch to, there we go. So we have decreasing and we have increasing. If you read it like a book left to right, this part is going up. We are increasing. Then you have to jump down, but on this part of the graph, this is technically still increasing. Okay. Then we start decreasing. So if we look from here all the way to the x value right here, we are increasing. Then we hit that x value and we start decreasing. Okay. All right, so now when we need to actually write this out, our increasing starts at -infinity. And it ends at the x value of 0. And if you notice, you guys, that x value is a vertex. It's a point of change. So that's a parenthesis. Then I start decreasing at that 0 point of change, and I decrease forever. Okay. All right, now we need to write the graph. Okay. So when I write the graph, a couple things. We always start with f of x or something of x. I use f all the time. Equals with a bracket. So why is that important? The f of x is making it a function. If you don't have the f of x, you don't have the y. Some of you guys have already gotten dinged for that. So make sure you have the f of x equals. Now, this big bracket, it doesn't need to be beautiful. Mine will look different every time. It's kind of like a little curly cube doodad thing. Just make sure something is there because it is telling mathematically that the functions are all grouped together in one function. All of these are pieces of the bigger function. Okay, so make sure you have that piece. Now, let's look. I'm going to erase this. Maybe, if I can find my eraser. There it is. Okay, so that we can just focus on the functions. And obviously, if you need to see that again, you can rewind in the video. Okay, but let's just focus on the functions. Remember, with functions, you need 3 things. You need to know what is the parent function. you need to know the critical point, and you need to know the A value. Okay. So that's just for writing the functions, which we did last week. So now, I'm going to look on the left. This is very clearly a snake graph. You guys find the middle, which, remember on a snake graph, this is my critical point. I know that because I have a point 1 to the right and a point 1 to the left. So my parent function is x, I'm sorry, cubed root of x. My critical point here is the point -2, -3. Notice we've bolded where the x and y axis are, so pay attention to that. And remember, to find your A value, you go to the right one, and then however far you need to go to get to your graph. In this case, we have to go up to. That is your A. So our first function here is going to be 2 times the cubed root of x minus a -2 minus 3. Okay, that tells me my critical point is at -2, 3. I have a cubed root graph. If I go right 1, I better go up 2, and I am. Now, for down here, this is a v, so I have absolute value of x as my parent function. My critical point here is at the point 0, -5, and my a value, if I go right 1, I'm going to go down to get to this point, so a is negative because I went down, and 1 because that's how far I went. So if I'm going to write that function, we have negative absolute value of x minus 0 minus 5. So 0, -5 is my critical point, which is, you don't have to write x minus 0, that's redundant. And obviously you don't need to put the 1 there if you don't want to. If you do, that's not a big deal. Now, the last part of this is those inequalities. So now you need to come up and say, okay, where is my breaking point and on which side, and where are my open circles and my closed circles? This is very clearly our breaking point because it's where we're switching from one graph to the other. Now, that means my breaking point is going to be at the x value of -1. So everything less than -1 is my cubed graph. So I'm going to say this is x is less than -1. Everything bigger than -1, remember it eats the bigger number, so x is greater than -1. The one last thing you need to check is your open and closed circles. The closed circle is up here with a cubed root graph, so that gets the equals to underneath it. And that would be your function. Okay, so as a quick recap, you start by writing f of x equals with the equation. You guys should know how to do this. This was on your homework and your review last week. I just wrote out the two equations based on parent function, critical point, a value. Then I determined where my breaking point was, and then my signs based on the fact that this was on the left, so less than, this was on the right, so greater than, and then this one needed the equals to because of the closed circle. All right, let's do that one more time. Okay. And this one has 3 pieces. So when we write that function, we'll have 3 functions. All right, let's start with domain and range. I have an arrow going to the right, or I'm sorry, to the left. So I know I'm going to start. I hit this point, I pick up another graph, and we have an arrow going. So our domain is -infinity to infinity. And I always double check, right? So when I get to the end of here, I can pick this up, keep going to the right. I can pick this up, keep going to the right. All right, now bottom to top, I don't have an arrow going down. These are both going up. The smallest y value I have is -1. So I come up my blue graph, and I run into my green graph, so that's good. I run into my red graph, so we're good. That's continuous. There is no break in the graph. Okay, so my range starts at -1 with a bracket because it's a closed circle, and it goes to infinity. So now let's do our increasing and decreasing. So my decreasing is yellow, my increasing is blue. Read it left to right. Here, I'm going to be decreasing because I'm coming down. Then when you jump to the next one, that graph happens to now be increasing. When I jump to the next graph, that's decreasing until I hit that point of change and start increasing again. Okay, so in both of these, do you notice how we go decreasing, increasing, decreasing, increasing. That means both of these are going to have a U in them because we have breaks in our graph. So we start increasing. Nope, let's start with decreasing. We start decreasing, there's an arrow, so all the way over at negative infinity. I'm going to decrease until I hit this x value. Then at that x value, I start increasing until I hit this x value. Then I start decreasing again until I hit this x value. Then I start increasing again forever. So let's look at what those x values are. This x value is -1. This x value is 1, and this x value is 2. So you should see those numbers coming up and increasing and decreasing. So we are decreasing from, oh, sorry, I didn't write it in. This is a decrease. This is a decrease. This is an increase. This is an increase. All right, so we are we start decreasing. So I always read it. I don't do like, okay, what are all my increasing? What are all my decreasing? Totally up to you. We start decreasing at negative infinity until we hit the x value of -1. That x value at -1 has an open circle there, so that's a parenthesis. Then I start increasing at, oops, -1. But if you notice that increasing -1, that's included there. So that's -1 with a bracket. You increase until you hit the x value of +1, which has an open circle, so that's a parenthesis. Then you come back down, put a U in there because it's a new section of decreasing, and we start decreasing, that's a closed circle, so 1, until we hit the x value of 2, that's a point of change because it is a vertex, so that's a parenthesis. Then I start at 2 with a parenthesis still because it's the point of change thing to infinity. Okay. All right. Now we need to write the piecewise function. So again, I am going to go ahead and I am going to erase all of this. So again, go back if you need to and pause the video and look at it. But I want a nice clean graph to write my functions on so I can easily see my open and closed circles and all that. So I'm always going to start with that f of x equals, and then give your big squiggle. Okay, we're going to have 3 functions here. Okay, so here, my green function, this is a cubed root graph. It's got the snake going. My critical point here is in the middle, right? I have a point 1 to the right, a point 1 to the left. That critical point is the point -2, +4. And if I go to the right one, remember that then tells you your a value. We went down 1, so that tells me that a is -1. Okay? Now let's go to our blue graph. Here, you guys, this is a straight line. That is a linear graph. So here I have y equals mx plus b. My b value is going to be 2 because that's my y-intercept. My slope here, I just have to find another point. Well, the next clean point is where it ends. I went up 3/1, so 3/1, my slope is 3. Last but not least, I have a quadratic here, okay? I have y equals x squared as my parent function. So this critical point is the point 2, 6. And my a value, if I go to the right one to get back up to my graph, I have to go up 2, so my a value is 2. All right, so let's piece this together. I always work left to right because then my inequalities will go in order. I have y equals negative cubed root of x minus a -2 plus 4. And I'll do the inequality in a minute. Okay. My middle graph is y equals mx plus b. So y equals 3x plus 2. I'll do the inequality in a minute. And my last graph is an x squared graph. I have 2 for my a value, x minus 2 squared plus 6. Okay, so now let's go back to those inequalities. Let's determine our breaking points first. So where do we switch from graph to graph? Right here we switch from graph to graph, and right here we switch from graph to graph. So I have a breaking point, one of them being at -1, and my other breaking point is at +1. Okay, so this cubed root graph is everything less than -1 with an open circle. So x is less than -1, no equals to there because you got that open circle right here. Then my line is between the x values of -1 and 1. Notice -1 is included with a closed circle, 1 is not included with an open circle. So from -1 less than or equal to, because of this closed circle, x is less than +1. Then once we hit +1, everything to the right of that with a closed circle is our last graph. So x is greater than or equal to +1. Okay, you guys, you should never have an equals to sitting on the same. And go back, do what you know. You know this should be an open circle. Is it? Yes, you know this should be a closed circle and an open circle. Is it? Yes, you know this should be a closed circle. Is it? Yeah, double check your work. Okay, and that's how you write that equation. So your homework tonight is going to focus on that. There aren't many because these do take a little bit longer. Your homework is worksheet number 8. This will be checked in tomorrow. You only have 4 questions, 2 on the front, 2 on the back, and you are doing all 4 domain range increasing and decreasing on them and writing the function. So take your time with it. This is going to really tell you if you know what you're doing or not. Okay, and then obviously tomorrow's going to be kind of a work day. We're going to have classwork, and it's a great time to answer questions, so bring those questions to class.